Hello, my name is Johnny Haboush. I'm a research scientist at the Virginia Transportation Research Council, the research division of Virginia Department of Transportation. I'll be discussing the performance test to evaluate the rutting performance of asphalt mixtures, the Asphalt Pavement Analyzer APA RUT test. This test is performed in accordance with AASHTO T340, standard method of test for determining rutting susceptibility of hot mix asphalt HMA using the Asphalt Pavement Analyzer APA. This method describes a procedure for testing the rutting susceptibility of hot mix asphalt using the Asphalt Pavement Analyzer APA. For the apparatus, we will need the Asphalt Pavement Analyzer APA and test molds. The machine should be able to maintain the test temperature and condition chamber within 1 degree Celsius, equivalent to 2 degrees Fahrenheit. The machine should be able to apply loads up to 578 Newton, equivalent to 130 pound force. The machine should be able to adjust and maintain the pressure in the test hose up to 862 kilopascal, equivalent to 125 psi. The machine should be capable of testing 4 or 6 cylindrical specimens, and the machine should have a programmable master cycle counter. The machine could have a rut depth measurement template, and then that will take into consideration the locations of the opening on the template that will coincide with the ones of the automated measurement system. We will be needing also ovens, compaction device, and molds. For the test specimens, the test specimen may be either laboratory compacted asphalt mixtures or sampled from asphalt pavements. For the lab compacted specimen, we may need 4 specimens in case we're using the APA Junior, or 6 specimens in case we're using the APA Senior. The compacted specimen shall have the following dimensions. For diameter, it's going to be 150 plus or minus 2 millimeter. For the height, it's going to be 75 plus or minus 2 millimeter. For specimen preparation, for the laboratory prepared specimen, we need to condition the loose mixtures for 2 hours at the design compaction temperature prior to compacting. So for the lab compacted specimen, we may need 4 or 6 specimens compacted using a gyratory machine to a height of 75 plus or minus 2 millimeter and a target air void of 7 plus or minus 0.5%. We need to allow specimens to cool down at room temperature for a minimum of 3 hours. For the field-produced specimens, we need to condition the loose mix for 2 hours at the design compaction temperature prior to compacting. For the lab compacted specimens, we could compact 4 or 6 specimens using a gyratory machine to a height of 75 plus or minus 2 millimeter and a target air void level of 7 plus or minus 0.5%. We need also to allow specimens to cool down at a room temperature for a minimum of 3 hours. For the roadway coarse specimens, the recommended diameter are somewhere between 140 and 152 millimeter. For height, we need a minimum of 50 millimeter tall cores with all surfaces within 5 millimeter. The testing shall be conducted on the uncut face of the core. For cores taller than 75 millimeter, we need to trim them with a saw to a height of 75 plus or minus 2 millimeter. For cores with diameter between 140 and 152 millimeter and or heights between 50 millimeter and 73 millimeter, we need to use a plaster of Paris or compatible material to ensure that specimens fit snugly within the mold and or to achieve the proper testing height. For testing temperature, the test temperature shall be set to the high temperature of the standard SuperPave Performance Grade (PG) binder identified by the specifying agency for the project for which the hot mix asphalt mixture is intended. In the case of Virginia, we're using 64 degrees Celsius. For the test procedure, in the following segment, we will present step by step how to perform an APA RUT test. Step 1. We need to compact 4 or 6 gyratory pills to 7 plus or minus 0.5% air voids. Step 2. We need to determine each specimen's diameter at 2 locations along the specimen. We need to determine each specimen thickness at 4 locations around the specimen. Step 3. We need to place the specimens in the test molds. We need to secure the specimens into the mold by tightening the sides, starting with the edges, followed by the center. Step 4. Specimens shall be conditioned at the test temperature for a minimum of 6 hours. Specimens should not be held at the testing temperature for more than 24 hours prior to testing. We need to set the hose pressure gap reading to 100 plus or minus 5 psi. We need to set the load cylinder pressure reading for each wheel to achieve a load of 100 plus or minus 5 pound force. We need to stabilize the chamber temperature at the selected testing temperature. Step 5. We need to secure the preheated molded specimen into the APA machine. We need to close the chamber doors and allow a minimum of 10 minutes for the temperature to stabilize prior to starting the test. Step 6, we need to initialize the APA computer software. We need to enter the applicable test parameters and project information prior to starting the test. We need to ensure that the cycle countdown mechanism is set to a value that will permit the specimens to be seated for 25 cycles and a complete test of 8,000 cycles. The APA machine will stop when the test is complete and the wheels will automatically retract. We need to save the rut depth data file to the computer and we can print the data if desired. For the test results, we need to calculate the average rut depth under each hose. So the following shows some of the data reported from the APA machine with automated measuring system to calculate an average rut depth after 8,000 cycles at 64 degrees Celsius. So after calculating the average rut depth after 8,000 cycles at 64 degrees Celsius, we need to compare this value to the balanced mix design threshold value of 8 millimeter. If the average rut depth is lower or equal to 8 mm, that means that the evaluated mixtures passes the rutting performance criterion. If the average rut depth is greater than 8 mm, that means the evaluated mixtures fail to pass the balanced mix design threshold criterion. This is a numerical example on how to handle the data. For example, from specimen 1 and 2, the rut depth measured after 8,000 cycles at 64 degrees Celsius is 3.968 mm. Meanwhile, the rut depths of specimen 3 and 4 measured after 8,000 cycles at the same temperature, 64 degrees Celsius, is 4.513 mm. The average rut depth after 8,000 cycles is equal to 4.241 mm. This value is lower than 8 mm, which is the BMD preset threshold. That means that the mixture passes the BMD rutting criteria. For precision and bias. For precision, the work is underway to develop precision statements for this standard. For the bias, the research required to establish the bias of the method has not been conducted. Okay, a simple example of data quality check. In this chart, we can see that the curve showing the variation of the rut depths function of the number of loading cycles shows a smooth curve with an expected trend. The average rut depth is increasing with the increase of number of loading cycles. Meanwhile, in this chart, we see some irregularities in the curve showing the variation of the rut depth function of the number of cycles of loading cycles, which could be caused by potential wobbling due to a bad hose or any functional issue of the APA rut machine itself. In this segment, I presented information related to one of the balanced mix design recommended tests to evaluate the rutting performance of asphalt mixtures in Virginia, the Asphalt Pavement Analyzer APA rut test. If you have any question, please do not hesitate to reach back to us. Thank you.